Let's solve question 51 from practice test 2. Question 51 says, a 2-mile taxi ride costs $3.90. A 5-mile ride in the same taxi costs $7.50. If X represents the miles driven and Y represents the cost in dollars, which linear equation models the cost of a taxi ride? Now, while this question is a little bit evil just because you are given this cost that's in decimal form, and then the answers in your test book are all in fractions, they actually give you a few nice things here that makes solving the problem a lot easier. For example, we know the cost of 2 taxi rides, and then they tell us if X represents this and Y represents that, which equation models the cost of a taxi ride. So if they're telling us what X and Y represent, that almost tells me, oh, I can make a little chart here that has the X values on one side and the Y values on the other side, because drawing charts like this help me solve problems when I'm dealing with linear equations. So this first part says a 2-mile taxi ride costs $3.90. So X represents the miles driven. So in here, 2 miles is our X value. And what's the cost? Y represents the cost in dollars. The cost was $3.90. But we need more than just one pair in our T-chart. So let's look at the next part of this question. A 5-mile ride in the same taxi costs $7.50. So if X represents the miles driven, we'll have 5 here. And $7.50 represents the cost in dollars. $7.50. So what we have here is actually all we need. It's almost like 2 coordinates here. All we need to solve this problem of writing a linear equation. Now you'll remember from earlier this year that linear equations usually look like this. Y equals mx plus b, where the y and the x kind of represent points on a coordinate grid, the x values and the y values. M, that stands for slope, and b stands for the y-intercept, or where that line crosses the y-axis. So we have only 2 sets of points. Now, what can we solve for really easily with these 2 sets of points? You guessed it, slope. Slope, we find, some people like to think of it as delta y, or change in y, over delta x. Some people like to think of it as y2 minus y1 over x2 minus x1. However you write it, let's solve for slope. So in this case, we're taking, let's call these the second ones and these are the first ones. So y2 is 750. I'm going to abbreviate that 7.5, take the 0 off, minus 390, or 3.9, divided by 5 from over here in the chart, the x values, minus 2. 7.5 minus 3.9 is 3.6. Oh dear, my screen's moving. 3.6. 5 minus 2 is 3. Now, here's where, I'm referencing this as kind of an evil problem. 3.6 divided by 3, if you did that on a calculator, you would get 1.2. Also known as 1 2/10. Now here's what I'm going to tell you. 1 2/10, you'll notice if you look at the answers in your test book, you see a bunch of fractions, 6/5 and 3/2. You also see a 3.6, but don't be thrown off because 3.6 is not equal to 3.6 divided by 3. We know that 3.6 divided by 3 is 1.2. But you can also say 1 2/10. So we could write that as a fraction, 1 2/10. How can I simplify 2/10? Well, 2 divided by 2 is 1, and 10 divided by 2 is 5. So I could write that as 1 and 1/5. Now how do we write 1 and 1/5? I'll write that over here as a mixed number. Well, that is 5 times 1 is 5, plus 1 is 6, and keep the denominator the same, 5. So we have 6/5. So we know we're going to somehow be dealing with 6/5 as our slope. So if you look back in your test book on number 51, page 69, you see 2 of the answers that have 6/5 as the slope. So you know the other 2, you can just cross those right out. They don't have the right slope. But now we're looking at this question, and we have a y equals 1.5 plus 6/5 x, or y equals negative 1.25 plus 6/5 x. So we need to find out what the b is in this. But we have an x value from over here. We also have a y value from over here. And now we know what m is. So we also know m could stand for 6/5, could stand for 1 and 1/5, could also stand for 1 and 2/10. So if I'm going to go back to working with decimals, I'll probably want to put my slope back into a decimal form, but keeping in mind it represents 6/5. So we eventually want something that looks like this, y equals mx plus b, and we're looking for the b value. So let's choose one of these points. This one looks a little easier to work with. So I'll say y. Well, my y there is 3.9, and that equals 1.2 times 2 plus b. Now let's solve this. All right, 1.2 times 2, that looks like the easiest one to solve. That is 2.4. So we're left with 2.4 plus b on this side and 3.9 on the other side of the equation, but we need to isolate b, get it by itself. So let's subtract 2.4 from both sides. Move the screen down here a little bit. 3.9 minus 2.4 is 1.5. 2.4 minus 2.4, that cancels out and is 0. So we get 1.5 equals b. So here we go with the question being a little bit evil again. You'll notice in your answer choices, they give you part of the answer is in a fraction, and part of the answer is in a decimal. But that's okay because we have all the right answers here. So if we put these back together, back in this y, not that y, in this y equals mx plus b format, we say y equals m, well that was 6/5, 6/5 x plus b. We just figured that out. That is 1.5. Now in your test book you might see something like y equals 1.5 plus 6/5 x, and that's okay. I just like to write it in exactly this mx plus b format, but you could also write it as y equals 1.5 plus 6/5 x. Good luck solving problems like this on the state test.